Hi, in this video, we're going to look at how to get information from our model after we fit a multidimensional item response theory model, a MIRT model. Okay, so a viewer of my YouTube channel reached out to me and said, "Hey, I'm having some trouble. I need some help," and sent me some code. Now, they didn't send me any data, but I was like, you know what, I'm going to go ahead and take their code, see what I can do with it, see if I can understand what's going on. And I'm going to use a data set that's available in R, and we're just going to work through this, and I'm going to hopefully answer his questions and help him out on his research project. Okay, so the goal, from my understanding from the message I received, is that he has a MIRT model. Now he wants to understand like aspects of that model. He wants to make inferences based off the model itself. And so I'm going to just work through, show some of the functions that you can use for this. And also, I think there's some surprises along the way. If you look at the help documentation for much of this package, it ends up using one factor frequently for its models. And with one factor, one latent variable, one under the hood variable driving what we observe, that's very different than the multi-dimensional versions of models. And so the help documentation, the examples don't always work out the moment we stretch from one to multiple factors. If I remember correctly, the viewer had 4 factors going on. For the examples I'm going to run with, I'm going to have 3. Okay, so first thing I'm going to do, as always, set up my workspace, make sure I don't have any gunk floating around. I'm going to make sure I don't get blasted in the face with long numbers, and I'm going to avoid scientific notation if I can. And I always like piping, so I'm going to use McGritter. All right, now for this is just basically fill-in data to show the concepts. I have no passion for this data set. I don't really know what's even in it. I didn't even read the documentation on it. I just know that it's in an item response theory package, and it looks like it's on reading, and it's got zeros and ones. Looks like it's probably a multiple choice test, something like that. All right, and so it's data.read. And now something that I like to do when I'm in a small data project is I'll order my data by either like something that makes sense, like the row sums, row averages, or possibly the first principal component. I find that this helps me spot trends. If I see something different between the top and the bottom of my data sets, then I know that that's a tip off to me that there might be something going on. And so by just ordering things that way, it's easier to spot what's going on, easier to check some things. So by doing the row means in this manner, I have it set up so that students who performed worse are at the top, students who performed better are at the bottom. And when I check my results, if I don't see the first one's doing worse, the last one's doing better, I know that there's something wonky going on, something weird. All right, now I don't know anything about this data set, so just to make a decision on what the factors should be, I've got 12 columns, and I decided to do 3 factors, and I just want to put 4 into each factor. And to decide on what those would be, I went ahead and just did row distance. Now, this is a very blunt, crude way because I've got binary data and I'm using Euclidean distance between the rows, but I think this is fine. This is not ideal difference between binary data, but I feel like it works pretty well for most of the cases. Honestly, my experience is that the results I would get with the proper way, proper metric, would be pretty close to this. And now I'm going to use complete linkage to just see what's similar to each other, and I'm going to visualize it. And so what I chose to do is I put A4, A3, B2, and B1 into one group. I put A1, B3, C1, C3 into one group, and then I put C2, C4, B4, A2 all into a group. So, this is as consistent with the dendrogram as I could get while having an equal number of questions for each factor. All right, and so now I'm going to go ahead and fit my multidimensional item response theory model, my MIRT model. And the first thing I'm going to do is I'm going to specify what is the structure of the model. And so I'm going to specify here is factor 1, factor 2, factor 3, and my covariance aspect. And so this indicates which column goes into factor one. So I went through, I mapped what I just articulated from the dendrogram to the column number, and it just works out exactly as I told you. And I went ahead and made sure that they're in order. I don't know if they need to be in order, but just to make sure in case the package when accepted, I went ahead and just went with it. And then for covariance, this is consistent with what the YouTube viewer gave me. Basically gave me like upper triangle aspects of pairwise, and the viewer would gave me like 1 through 4, 5 through 8, 9 through 12, 13 through 16 as the different factors, something like that. It doesn't really matter. Just we're getting it in there. For your individual project, you'll have to be your factors will have to reflect what you believe is going on. All right, so now let's actually fit our model. Now, what I've done here, these are the actual values that the viewer put into his code. And so are these the best ones to go with? Maybe, maybe not. For this data set, I would not have gone with graded. I would have gone probably with a rash model. This is, my graded is for like a graded response where you get partial credit. Here, I'm using binary data, so these don't match, but the goal is to help a specific person out. And so I'm just going to go ahead and leave it how they had it to make sure that things are consistent. And so, model is set up exactly how I set up here. Now I am changing the names of things from his just to make sure that if there's anything that he really shouldn't have shown me within his code, like there won't be any, anything popping up. And so, we just went through and just slapped those in. And now here we get the progress report as the model is being fitted. You can see that's pretty long. As long as things converge and the model looks good, I really don't care. If I'm having trouble getting things to converge, if things don't look like they should when it's all done, I'll be using this to diagnose. But in my experience, I've never had a problem with that. As long as I set up like coherent good factors, things tend to work out well. All right, so the viewer needs to get the coefficients out. And so here I'm taking the model, and here I'm saying, item response theory parameters, get those, and simplify equals true. That will set things up to be easier into like these data frame formats. And so we can see here's the information for the items. And so we can see the coefficients as they go in from each column to each factor. And so we can see that A3 is part of the A1, A4 is part of the A1. So by how I set it up, like each column in the original data is only going into one factor. That's a much simpler model structure. Things will be more complicated and more nuanced to work through the code if you have any columns going into more than one a factor. But you can just see like the connections like here. These are the ones for the second, and here are the ones for the third. All right. And now here are the means. We can see that's all 0 by how it was built. Here's my covariance matrix. All right, now let's go ahead and get the factor estimates. Now this is going to be the estimate of student proficiency off of this for each individual. So each factor corresponds to how proficient a student is. And so this is something this is where things get very different from the help documentation. So in the help documentation, there's only one factor. So in the help examples, they just drop it straight in and run code, and it's not a problem. Well, here we have to make a choice on which of the 3 are we actually going to take a look at. So just to emphasize that there's 3 columns, I went ahead and did a histogram of each of the columns just so that we can get an idea of what's going on. And remember that things average out to be 0. And notice how the range of values are not symmetric about one. In this particular data set, there's a good number of students who are highly performing. If I want a more sensitive model, I would like ideally for all my questions to have a 50-50 success rate. Things will be more sensitive that way. I know that that contradicts the way that we normally teach of like 90% is an A. If I do 50-50 is typical, then we're, then we're actually just blow people out of the water and everybody would be getting Fs. It's not a good situation. Don't do it if you're a teacher, but just know that if for the purpose of item response theory, the best question possible will be 50-50. When I end up getting like 90%, for a good number of students, you can see we have a lumping at a very relatively small positive values, and then the students who are not getting an A are more distributed throughout. It's very, very lopsided and skewed. All right, so now let's calculate the test information. Okay, so the MIRT package gives us a function, test info, to extract this for us very nicely. And this ends up just being a vector. So it comes out. And here, if you look at the help documentation just dropped the output from F scores straight in. Well, there's only one factor that made sense. Here, I've got 3 to deal with. And so I'm going to go through, I'm going to plot them. So here I have the test info and is on the vertical axis. And I have the factor for each student for each of the groups of questions as the horizontal axis. And so we can see that things are relatively flat. There might be something going on in, if I was to take an average, but I definitely have some outliers going on in here. So something I would have to address to interpret this model. This might look better if I took the test information and truncated everything down to, like, if it's greater than, let's say 5, I reduce it to 5, or greater than 4, 3, something like that. All right, now here we see here are the students, the scores in terms of the second factor, and then I have test information, and we can see that we have a curve going on here. So something interesting is going on. I would definitely want to dig into this deeper. I don't know the data. I don't know the situation that data was collected in. So I'm just going to leave it as is, but this is definitely piquing my interest. I want to dig into this. And now we see something similar to the first one and the third, where there might be a trend happening. There might be something going on, but things are getting getting squished out by the extreme scale. So I would definitely want to do something like maybe reduce the test information. If it's greater than 4, replace it with 4, and then replot this and see what's going on. All right, so what I did previously was for test information. The test information was for the entire test in relation to individual students. Now what we want to do, we want to take a look at each individual item. And this is a modified version of the viewer's code, by the way. So here, what I'm doing is, with extract item, I'm taking one question and I'm going to extract its information out of there. Now, if you print this, it's just going to say like a graded response. That's all it's going to say. The R is kind of dumb on this, but there's a lot more going on with this that we don't see. If I use the str function, I can see all the slots that are associated with this. And so if we need specific information about each individual item, we can go in and use str just to see what is contained inside that object, and then I'm able to extract it. Now, when I use the str function, how I extract something corresponds directly to the symbol here. Usually it's either going to be a $sign or it's going to be an @ All right, so there's going to be, the way that I know of, 5 ways to get something out of a slot. There's going to be a function to extract that's called slot. There's going to be $, which is not applicable here, but if I saw a $, I would be using $. That's the most common thing you'll see in str. The third way is when I see the @ symbol. And so with the @ symbol, I just say item, it's slot, and I put an @ in between. If I had a $sign here instead, if there was a $sign, I would put a $sign instead. Now, the next way is to use brackets and use quotations on the name of the slot, and the last one is double brackets, then quotations on the name. Individual objects will require different approaches to extract slots. And it will correspond to the class of the item. And so you just gotta like look at it, figure it out, work through it. I always start with str, try the symbol first. If the symbol doesn't work, then I'll go into brackets, single brackets with quotations. If that doesn't work, double brackets with quotations around the name. And if that still doesn't work, use a slot function is how I typically proceed. But so here, this is how I get, the parameter aspect. And so we can see how much this individual question contributed to the second factor. All right, well, of course, you're not going to just want one item from your test. You're going to want all items. And so to be able to extract that relatively quickly, I'm going to use the sapply function. What I'm going to do, I'm going to use exactly the same function I used a moment ago, but I'm going to iterate it over all the columns. So here I have 12 questions in my test, so it's 1 through 12 are how it's coded in the system. And so what I'm doing is item is 1 through 12 corresponds to the columns, and I'm just extracting it here this way. And so what this will do, this will set me up very nicely to have everything in a list so that I can grab it very easily for anything else I want to do. I could have also done this in a for loop, but I like sapply, lapply. In general, for loops are slow compared to other languages. It's not that big of a deal, but sapply tends to be a little bit slicker in my opinion. And so I like doing this. This is similar to like using a Lambda function in Python. All right, so now let's actually compute item information. All right, so we're going to compute the item information using the extracted information for the items we got just a moment ago in the code block above. All right, so here we're interested in the student's abilities over all possibilities. And so I'm interested, so we're no longer interested in individual students. We're interested in what does the model tell me about how well a student would perform given they had a particular proficiency level for each factor. And so what we're going to do to set that up, so this is like my scoring set in machine learning. So here, this is my score data. I'm interested in, I want to know all the possibilities that would happen. Okay, and so now, what I'm going to do to get that, I'm going to do item info. Here is the item that I'm interested in. I'm going to specify the proficiency on each of the factors I have, which is set up in this part of the code. Now the degrees, that deals with the oblique rotation, and the viewer put in all zeros. So I went ahead and just put in all zeros. That will definitely change depending on your project. Compute total info, yes. Give me a multidimensional matrix, yes. And so now I've got it spitting out this way. And these are parameters that the viewer gave me. And so you can see for each individual student in my score data set, so each row here corresponds to a fictitious student whose abilities are are set by the matrix row. All right, and they go from -4 to 4 for each of them in all possible combinations. And so we can see for each individual row of theta, each row corresponds to a fictitious student, I get the output like this. And you can see I've got a lot, I've got a bunch. I'm going to scroll for a while. I wanted to show exactly the structure. Sometimes people get stuck on what is the structure of the items that they're producing. So I went ahead and just vomited this onto the page. All right, so now let's do this another way. Let's go through and do the same thing, but not for just one question. Let's do it for all questions. Okay, so I'm going to go through and I want to get the extracted items I did previously, and I want to, for each extracted item information, I'm going to put it into the item info function here. I'm going to say, hey, here are my fictitious students. and then same values as I had before, and it's going to produce it. Now, notice I have all these matrices with a whole bunch of zeros. I look through and every single matrix for this particular model, not necessarily your model, not necessarily the viewer's model, but for the one that I built here and now, every matrix is all zeros except for one value. So you know what? I'm just going to go through and extract that. And this for loop is kind of ugly, but I went through and just extracted all of the non-zero entries, and here I saved it into a data frame. And so I'm getting all of the list of matrices. So I have a list of matrices, and I have, for each question, I have a list of matrices, and I have a list of those. So I have a list within a list going on. And so I'm going to iterate over it, and I'm going to, for each item information, I'm going to go through and iterate over its list, and then I'm going to take the matrix that we have, going to convert it to a vector, get rid of all the zeros, and then put it into here. Now, something I'm going to do is, if it ends up that it was all zeros, and it never is for my data set, but it potentially could be that way, then I'm just going to put in a 0 for it. And then, so I've got a list of individual entries. So I'm going to make it into a list of vectors using the unlist function. And then I'm going to take all the vectors and put them into a data frame. And boom, I've got this. So now I've got the results for each individual student. And you'll notice that the columns that have variation, initially up at the top, those correspond to factor 1. When these are all the questions that I said, hey, put into factor 1, you'll notice I have variation. And that's not a coincidence. That's how the expand grid function was generated all the different rows. Here for the part that's visualized, the top of theta, the score data set, the theoretical values for the students all have, it will be all -4, -4, for the other two factors for all these rows. And we can also scrutinize it further. All right. So we reviewed how to fit a MIRT model and how to set up the structure of the model, how to fit it, and then how to extract item information, how to get the test information, and then how to further get more information out of the extracted item info. All right. Well, that's all I've got for you. Life is short. Do math.